Day 29 Movie Rating Prediction using Collaborative Filtering. The project overview here is to build a movie rating prediction system using collaborative filter where the model predicts how a user would rate a movie based on historical user movie interactions. The goal here is to predict movie ratings for users, and the approach that we'll be using is collaborative filtering with techniques like matrix factorization, example singular value decomposition, also known as SVD. So first, we're going to get some data set from the Movie Lens dataset, which is available in Movie Lens website. So you can go to this website here, grouplens.org dataset Movie Lens, and here you'll find recommended for new research. There's like smaller size available. There's also 1.8 GB. There's also recommended for education and development. Since I don't have that much time, I'm just going to download this small one, which I have already downloaded. That will give you something like this, which has links, movies, readme, and tags.csv. In this case, I am interested in, there's a file called as ratings.csv, which I've already moved here, ratings.csv, and we have four different rows here. One is user ID, which is unique identifier for users. We have movie ID, which is unique identifier for the movies. We have rating, which is rating given by a user, which is from 1 to 5, depending on that. And then we have the timestamp, which is time of the rating. Not essential for this project, but that's available there. Timestamp doesn't matter, as you can imagine. So anyway, let's go ahead and implement this project. So I've created a day 29 file here, which is empty, and I'm going to write this code and go over each line of code with you. So first step, let's go ahead and import the libraries. So first I need pandas pd, pandas spd, which is data manipulation and analysis library. Next, I'm going to import numpy as np, which is a numerical computation library. Next, I need from surprise import svd. Now you might not have surprise available. You can just say pip install surprise and will work. This will work. If you get an error, just do that, pip install surprise. This is singular value decomposition algorithm from the surprise library used for collaborative filtering. Next, I'm going to get dataset and reader from surprise. Dataset is used to build a dataset from raw data, and reader helps defines the rating scale and dataset structure. Next, I'm going to import cross-validate and train test split from surprise.model selection. Now this train test split, again same as other one, which splits data set into training and testing sets. Next, we'll get accuracy, which contains metrics, example RMSE for evaluating models. That's what we'll be using. Next, I'm going to import Seaborn as SNS, which is visualization library for creating statistical plots. And finally, I'm going to import matplotlib.pyplot as PLT, which is a core plotting library for visualization. Next step, let's go ahead and load the dataset. We'll load the movie lens dataset here. I'm going to say df equal to pd.read CSV ratings.csv. So this will load this data set here. Now depending on which one you have selected, it will take that much time. This is the small one, and even this one has 100,000 rows here. So depending on which one you use, it will take that much time. Again, depending on how much time you want to spend or how better you want to build the model, you can pick that data set. Next, I'm going to drop, as I mentioned, timestamp is not required. So I'm going to go ahead and drop that timestamp access equal to 1 in place equal to true. This does is this removes the timestamp column as it's irrelevant for collaborative filtering. Anyways, moving forward, I'm going to go ahead and display the first few rows. As you know how to do that, print dataset preview and df.head is what I'll print. This will give us user ID, movie ID, and rating will be printed out. So next, let's go ahead and do the pre-processing the dataset where we define a reader object for surprise. So what we're going to do here is first reader equal to reader rating scale equal to 1 to 5, which defines the range of ratings in the dataset. Next, I'm going to say data equal to dataset load from df user ID, movie ID, rating, reader. So what this does is it loads the dataset into a format compatible with surprise. Input equal to user ID, movie ID, and rating, and surprise expects a dataset with 3 columns: user ID, item ID, and rating. So let's go ahead and do the step 3, which is split data set into training and testing sets. So for that, I'm going to say train set, comma test set equal to train test split. We'll pass the data to it that we have created. Test size 0.2, random state equal to 42. Again, train test split splits the data into training and testing sets. Test size 0.2 reserves 20% of the data for testing, and random state equal to 42 ensures reproducibility. Every time you use this number, it will give the exact same training set and test set. Train set that we get out of here will be the training data used for to train the model, and test set will be testing data used for evaluation. Next, let's go ahead and build the collaborative filtering model using SVD. For this, I'm going to say model equal to SVD brackets, which initializes the singular value decomposition or SVD model. Next, I'm going to say model.fit train set. I'll pass it the train set. This trains the model on the training data set. The SVD model predicts ratings for user item pairs based on the latent factors. So let's go ahead and evaluate the model next. So here I'm going to say predictions equal to model dot test set. This tests the model on test data set and generates predictions. Next I'm going to say RMSE equal to accuracy dot RMSE predictions. This calculates the root mean square error, which is RMSE, and RMSE measures the difference between predicted and actual ratings, and lower RMSE indicates better performance. And predictions is a list of predicted ratings for the user input pairs that we get from here. So let's go ahead and print this RMSE so we can see how it looks like. I'm going to use up till 4 decimal points here. Next, I'm going to make a prediction for a specific user and movie. So I'm going to go ahead and say, let's say user ID is something like 196 and movie ID is 242. Give me the predicted rating for this. I'll say model.predict based on this user ID, movie ID, and give me an estimate. So this will print predicted rating for user. I'll pass the user ID on movie ID, and the predicted rating for that. That's what this will give us. So again, the model.predict above predicts the rating for a specific user ID and the movie ID that we have passed. .est extracts the predicted rating, and this will print out the predicted rating for user. So that brings us to the next one, which is visualize distribution of ratings. So here I'm going to use plt.figure fixed size 10,6, which says the plot size, snh.histplot df of rating bins equal to 5, KDE equal to true, which creates a histogram of movie ratings. Bins equal to 5 divides the rating into 5 different groups, and KDE equal to true displays a smooth kernel density estimate. So next I'm going to say plot.title. This will add the title. This will give the X label of rating. This will give the Y label for frequency in the graph, and then finally I'll say plot.show. So in this particular project, we have loaded a data set. We imported the user movie ratings. We pre-processed the data set. We structured the data for the surprise library, and then we split the training and testing data sets. We built the model. We trained the SVD model, and then we used the RMSE for performance evaluation here, and we made predictions with some user item pairs here, and then we visualized the data using matplotlib and Seaborn. So let's go ahead and see if it actually works. We've done all the work, but let's see if it works. I'm going to say Python day29.py, run it. It's going to go through the data. As you can see here, it gave me some sample data here. I got the RMSE of 0.87, RMSE 0.87, predicted rating for user 196 on movie 242 is 3.62. That will be the predicted rating that user will give. And then we plotted the graph, as I said, created 5 bins, and it went through each and every data and showed the distribution of movie ratings based on that. And it looks like the most movie ratings were given as 4 for most of the ratings, but we have a good distribution here. So I hope you were able to follow along and implement this code. If you have any questions or had any issues while working with this, let me know in the messages and I'll get back to you.